Hello everyone. I hope you all are doing good. We are back here with the second lesson of chapter number 1, Experimentation and Measurement of class 9 ICSE. So let's start with the second module. Measurement and Experimentation, the second module. Let's have a quick recapitulation of what we have already studied in lesson 1. What are fundamental units? What is the other name for unit? If meter is for length, then Kelvin is for? What is the need for measurement? Think about the questions and do answer. So today's topic is simple pendulum. What is a simple pendulum? It's a very simple setup where a bob is tied with a thread, or also known as string, and suspended from a fixed point. You can see here in the diagram as well. And the motion which this simple pendulum undergoes is called an oscillatory motion. Why? Because it oscillates from one end to the other. Simple pendulum is used to measure time. A very common pendulum which you all must have seen is in the pendulum clocks we mostly have in our houses. The terms related to a simple pendulum: oscillation. One complete to and fro motion is one oscillation. In simple words, the motion which the simple pendulum undergoes is the oscillatory motion, as just told earlier. One complete to and fro motion means from one end to the other and coming back to the first end. Amplitude: maximum displacement from mean position to extreme position is called amplitude of the pendulum. It's measured in meter and denoted by small a. Time period, or also known simply as period, it is the time taken by one oscillation, measured in seconds and denoted by capital T. Frequency: it is the number of oscillations in 1 second. It is measured in hertz, and also it's the other unit is per second. It is denoted by small f. Effective length: the distance from the suspended point to the center of the bob is the length of the pendulum. The diagram here shows the length of the pendulum, the mean position, the extreme position, the amplitude, point of suspension, and the rigid support. When we say or talk about amplitude, as I just mentioned, it is the maximum displacement from mean position to the extreme position. That means, with respect to this figure, the distance traveled from B to C or from B to A. And when we talk about one complete oscillation, it is either starting from one extreme position and coming back to the same, or starting from mean position, reaching the extreme position 1, then second, and coming back to B. For this diagram, starting from B, moving towards A, then towards C, and then coming back to B, completes one oscillation. Then we have the relationship between the time period and frequency of a simple pendulum. They are inversely proportional to each other. That means with increase in time period, the frequency decreases, and with increase in frequency, the time period decreases. Next, we have the factors affecting the time period of a simple pendulum. The first factor is the length of the pendulum. The time period of a pendulum is directly proportional to the square root of the length of the pendulum. That means if the length of the pendulum is increased, the time period for that pendulum will also increase. Now, as frequency and time period are inversely proportional to each other, that means length of the pendulum is also inversely proportional to the frequency. How? Frequency is inversely proportional to square root of length. The second factor which affects is the acceleration due to gravity. The time period of a pendulum is inversely proportional to square root of acceleration due to gravity. That means the frequency will be directly proportional to acceleration due to gravity. Combining these two results, we can say that T is proportional to square root of length upon acceleration due to gravity. And in terms of frequency, frequency is proportional to square root of acceleration due to gravity by length. Removing the proportionality sign with a constant 2 pi. We all know 2 is a numeric value, it's a constant. Same way pi has a fixed value, that is 3.14 or 22 upon 7, again a constant. So this is a formula which is mostly used to calculate the time period of a pendulum, knowing the length and of course the acceleration due to gravity. The factors which do not affect the time period or frequency of a simple pendulum are the mass, weight, or material of the bob and its amplitude. For example, if we have two pendulums of same length, but one has a bob made up of glass and the other has a bob made up of iron. As their lengths are same, their time period will also remain same. The material of the bob won't affect the time period of the pendulums. Next, the length versus time square graph for a simple pendulum. If the graph between the length of the pendulum and the time period is plotted, it is a curve. To get a straight line, square of time period is taken. And experimentally, the slope of this graph is equal to 4 pi square upon acceleration due to gravity. Few numerical problems on time period formula as well as relationship between time period and frequency. Let's see the first one. Question reads, what is the period of a simple pendulum of a length 1 meter? Use 9.8 meters square for gravity. We'll use the formula for simple pendulum, that is T is equal to 2 pi square root of L upon G. We will substitute the value of L and G here. Substituting the values, we get T is equal to 2 pi into 0.32 seconds. Substituting the values of pi, we get time period as 2 seconds. Now here is an interesting fact for you all, that such a pendulum whose time period is 2 seconds is called a seconds pendulum. Its length is fixed, that is 1 meter, and this is the pendulum which is used mostly in the clocks which we see in our houses. Next, Freda the fly flaps its wings back and forth 121 times each second. Each second means 1 second. The period of the wing flapping is how many seconds? So we have got that it moves it 121 times each second. That means its frequency is 121 times per second. So what will be the time period? We know that time period is reciprocal of frequency. That means it will be equal to 1 upon 121, that is 0.00826 seconds. That's an interesting fact, that a fly can flap its wings 121 times in 1 second. Amazing. Let's see the next question. A tennis coach paces back and forth along the sideline 10 times in 2 minutes. The frequency of a pacing is? Now see here, the time given to us is 2 minutes. Do remember, whenever solving a numerical, every physical quantity should be in its SI unit. That means 2 minutes needs to be converted into seconds, which comes out to be 120 seconds. We have to calculate frequency, simple unitary method, and we get a value as 0.0833 cycles per second. So these were few numericals based on the formulae and the relations discussed in this lesson. And here are a few questions for you to think over it and do answer. What is a simple pendulum? Time period of a simple pendulum depends on the mass of the bob. Is it true or false? Slope of length versus time squared graph is. Non-digital clocks, which of course are becoming rare these days as we are more towards the smartwatches, have a second hand that rotates around a regular and repeating fashion. The frequency of rotation of a second hand on a clock is, here are your options. So this is it, and here we come to the end of the chapter by completing these two lessons. And the points what we have covered in these two lessons are the idea of a physical quantity, unit and its basic characteristic, and of course the need for measurement. The difference between the fundamental and derived units, the concept of system of units, FPS, CGS and international systems, the concept of simple pendulum and its time period and frequency, and the relation of course between both of them, factors affecting time period and frequency of a simple pendulum, and the graph between the length and time period of a simple pendulum. Hope you all enjoyed this lesson as well. Do come back with your queries if any. Thank you.